Hello everyone, in this video I'm going to solve problem 37 of chapter 9. We're going to locate the centroid of this circular sector. This circular sector is an area, and the equations for the centroid of an area is x bar is x tilde dA over dA, and for y bar we have y tilde dA over dA. So our first task is to find x tilde and y tilde, which are the centroid of our differential element. Because I want to find the centroid of a circular sector, my differential element would be a circular sector as well. So I need to find the centroid of this circular sector, x tilde and y tilde. I'm gonna draw this circular sector here. We can think of this circular sector and simplify it as a right triangle with an area of R, with the radius of R, the angle d theta, and this differential element is located at a random location of theta. So we know the centroid of a rectangle would be 2/3 from the right side. So that would be somewhere here. And because we have theta, this distance, or x tilde, would be 2/3 of r cosine theta, and the y tilde would be 2/3 of r sine theta, because we know the distance of the centroid from the right side of a triangle. So now that I have my x tilde and y tilde, the next task is to find the area of this differential element. So if the radius is r, this distance would be r d theta, and the area of a triangle is simply the base times the height divided by 2. So half r squared d theta. Now that I have dA and x tilde and y tilde here, I can plug it into equation and find my centroid. Y bar is 0 because we have symmetric. But I'm gonna find x bar. So x bar is x tilde dA over dA. Let's plug in the value. X tilde is 2/3 of r cosine theta. dA is half r squared d theta. And ranging of theta is from negative alpha to positive alpha. Similarly for dA, half r squared d theta, from negative alpha to positive alpha. So I can simplify this. These are half, and half would go away. Then here I have 2/3 r cubed cosine theta d theta, from negative alpha to positive alpha. And here r2, the integral for d theta would be theta ranging from positive alpha to negative alpha. That would be alpha minus negative alpha, which is 2 alpha. And here I have 2/3 of r squared. The integral of cosine theta would be sine theta, and then sine theta would be ranging from negative alpha to positive alpha, which this would be 2 sine alpha. So after simplification, I have 2r sine alpha, 3 alpha. And according to symmetry, y bar would be 0. So I found x bar and y bar of this circular sector.